Hello everybody, this is Yusuf Saleh, a chemistry teacher. We will go on our mini lectures of chemistry for grade 12. I think we reached section 2 and chapter 1, and exactly we reached, the elevation of boiling point or boiling point elevation. We have studied before the depression of freezing point, and we have studied also in last lecture, we studied the vapor pressure. Today we're going to study the third qualitative property, which is boiling point elevation. Of course, the term elevation means raising. So the presence of particles of solute within the solvent raises the boiling point. This is exactly the principle on which the car radiator water or solution works. They put some ethylene glycol in the car radiator mixed with water, so it makes the solution boils at higher than 100 and freezes lower than 0. So this is the principle of depression of freezing point and elevation of boiling point. Let's see how does this happen. Boiling point is a point at which vapor pressure equals atmospheric pressure. So the definition for what? For boiling point. Okay, we have the justification here for raising or elevation of boiling point when adding some solute, when mixing some solute to the solvent. So the solution has a boiling point higher than the boiling point of the solvent. Why? The justification has said dissolving a non-electrolyte, which means a non-electrolyte solute in water, boiling point of water or of the solution raises. This justification, how we justify this change? When dissolving non-electrolyte substance or even if electrolyte, vapor pressure decrease, we need to raise it in order to get it equal to atmospheric pressure. So in order to raise the vapor pressure, we need to heat the solution more. So more heat, higher temperature. So presence of the solute within the solvent makes the solution boil at higher temperature than the initial boiling point, which is the boiling point of the solvent. So here we have vapor pressure decrease, so temperature must be increased in order to increase vapor pressure and make it equal or get it equal to atmospheric pressure, which means raising boiling point. So always the solution has a higher boiling point than the pure solvent. For example, we have a solution of sucrose. 1 molar has higher boiling point and lower freezing point than the pure solvent, which is water, that boils at 100 Celsius and freezes at 0 Celsius. Okay, now let's move to mathematical applications or mathematical relationship. We had the delta TB equals KB times molarity. We're talking about non-electrolytic solution, which means solution of sucrose, solution of fructose, solution of glucose, solution of alcohol, solution of ethylene glycol, despite it's also alcohol. So these are non-electrolytes. We're gonna calculate, we're gonna find the change or the elevation of the boiling point by multiplying the molar concentration of the solution times Kb. What is Kb? Kb is the constant of boiling point elevation. Each solvent has its own Kb. For example, for water, the Kb equals, of course, plus, because it elevates, plus 0.51. Kb for water is 0.51 Celsius for molar, which means for each molar, the boiling point of water raises by 0.51 Celsius for each molar. So if you have 2 molar of non-electrolyte, of course it will be multiplied by 2, which means 1.02. Of course, the delta TB equals the TB final, which means boiling point of the final of the solution minus TB initial, boiling point of the solvent. Most of cases, the solvent is water. Sometimes it's not water. So its boiling point is being given. Now, we have here the TB means, actually here delta TB. The TB is boiling point, but delta TB, there is delta forgotten here. We must put delta here. So the delta TB means the elevation in boiling point, the change in boiling point. And Kb is molar boiling point constant. We said for water it is 0.51. Molality M, italic M, it is molality. Okay, now let's move forward and have some practice. We have practice 4 in your book on page 47. The boiling point of an aqueous solution containing non-volatile electrolyte is 100.75. Okay, this is the boiling point of the solution. What is the boiling point elevation? And what is the molality of the solution? Okay, how we deal with such question? First of all, we need to read the question 3 times. Okay, we have the boiling point, final boiling point. This is not delta TB, this is the final. So the delta TB here, okay, we have the delta TB always equal TB final, which means of the solution, minus what? TB initial. This is for the solvent. And the solvent here is water. So what we have here? We have 100.75 cils minus 100 minus 100 cils. This equals 0.75 cils. Okay. This is about the delta TB. Our next step, we need to find the molality. We have the delta TB and also we have the Kb for what we said before. It is 0.51. So we will say here the delta TB also, delta TB equals Kb of water, of course. Why? Because we have aqueous solution times molar concentration. Molar concentration. We have the delta TB, we have the Kb, but we don't have the molar concentration, which means the molar concentration here, molar concentration equals delta TB divided by what? By Kb. By Kb. And this equals, the delta TB is 0.75 divided by 0.51. Sorry, 51, not 15. 0.51. Okay. This is 0.51. This equals about to be how many? 1.5. It is about 1.5. So what is the 1.5? Is molar, which means mole per kilogram. Mole solute by 1 kilogram of the solvent. Let's move forward. What should we do now? We have the molality and it says what? What is the boiling point elevation? This is the boiling point elevation we already found. And what is the molality? And this is the molality. The question here is, this is the simple form of questions. Sometimes the question requires mass or gives mass and requires the delta TB. Let's have another example that involves, here we have a solution containing, this is the mass, a solution containing 450 gram of sucrose, C12H22 or 11. Let's remove the, okay, we have, this is mass, this is not molality, this is mass of the solute. And an electrolyte dissolve it in 250 grams of water. So this is the mass of the solvent, but not in kilograms. We need to convert it into what? Into kilograms. Also, we have the molar mass of the sucrose, which is 342.34 gram per mole. So what should we do? We need first to find the molality, the molar concentration. The molar concentration equals always moles, of course, moles of the solute. Divide by what? Kilograms of solvent. The moles always, if we have the mass and the molar mass, we're going to divide the mass by what? By molar mass. Okay, so we have 450 grams divided by 342 and 0.34 divided by, what are the kilograms? Kilograms of the solvent. We have the grams here, 250. 250 divided by 1000. So this becomes 0.25 kilogram. Okay. This is our first step. And it's found to be 5.2 in total. This is 5.2 molar. Okay, we found the molality. This is 5.2. Next step. What does it say? What is the boiling point elevation? We have the molality. We're going to check now for the delta TB equals KB times molar concentration. And we recall that so far we deal with non-electrolytic solutions, because when we reach electrolytic solutions, the relationship will differ a little bit. So we have here 0.51, which is the KB of water, times the molar concentration we already found, 5.2. This equals about 3, or a little bit greater than 3. Let's see the result here. The result here is, okay, KB 0.5 times 0. Okay, here is 2 point, sorry, it is 2.65 Celsius. So what is the boiling point of the solution? It is the initial, which is 100, plus what? Plus 2.65 Celsius, and this is the final. So this is the second type of questions. We have another possibility of a question. If you have the delta TB and you have let's say the KB, which is the constant of boiling point elevation, and required the mass. Of course, in this case, you need the molar mass also. So the molar mass must be given. Let's move forward and see a question similar to this. Okay, this is the freezing point we studied before. Let's check for another question similar to osmotic pressure. Okay, let's check here for a similar question. Just a minute. Okay, delta TF and delta TB. I think input. Okay. In section review questions, okay, let's check this. This is the electrolyte. We need to sorry. Okay, let's make a question. ask ourselves a question and solve it here. Okay, have justification solution of molar concentration. This is 2.61. Okay, let's move. This is electrolyte. This is also electrolyte. We will study later. Okay, this is also electrolyte. We will study later. Okay. Okay, now let's have a space here and write a question. Okay, now, sorry. Let's have a space. Okay, we have solution of sucrose C12H22O11. This boils at 101.02 Celsius. How many grams of sugar, of course the sugar is sucrose, of sugar dissolved in 1 kilogram water when preparing the solution? Of course, we will have the molar mass here. We will say the molar mass of sucrose C12H22O11 equals 342 gram per mole. In this case, what should we do? First, we need to find the molality. After we find the molality, this is our first step. Second, we're going to find the moles of the solute. Third, we're going to multiply the moles of the solute by what? By the molar mass. So we're going to do this calculation in 3 steps. So first we have the delta TB equals molally times Kb, or Kb times molally, which means the molar concentration equals delta TB divided by what? Divided by Kb. Of course, this equals the delta TB. We have it boils at 101.02. So how many degrees this upper than normal? This upper than 100, of course, it is 1.02 Celsius divided by Kb, which is 0.51. 0.51, let's get it clear. Okay, we have 0.51. Okay, 0.51. Of course, this equals 2. Here we have 2. So this is the molality. This is the molality. What I use of molality? We need the molality in order to find the moles. Moles equal moles of solute, of course, equal molar concentration times kilograms of the solvent. So this equals, the molality is 2 times 3, 4, 2. This equals, times the kilograms, which is 2, times kilograms. And how many kilograms here? The question says in 1 kilogram. It's times 1 kilogram. Times 1 kilogram. 1 kilogram equals 2 moles. So we have how many moles? We have 2 moles. This is our second step. The third step, let's move up. Okay, now we can find the mass. Mass equals mass. Mass of the solute equals moles times molar mass. Moles times molar mass equals 2 times 342. And this equals 684 grams of sugar. Let's revise it. We have in the question, we have the solution that boils at 101.02 celsius. So what is the delta TB? The delta TB is 1.02. How many grams? What is the mass of the sugar, which is the solute that dissolved in 1 kilogram of the solvent, which is water? Now, the first thing we should decide, what is the delta TB? Delta TB is 101.02 minus the initial, which is 100. So the delta TB here is 1.02. In order to find the molality, we will say the molality equals delta TB divided by Kb. Delta TB divided by Kb of water. So this equals how many? This equals 2 molar. Later, we're going to find the moles. Moles equal molarity times kilograms of the solvent. 2 times 1 kilogram, because we have 1 kilogram here. So you have 2 moles. And finally, we're going to find the mass of the solute, multiple the moles of the solute times its molar mass. 2 times 342. Of course, this will be given, equals 684 grams. Let's move forward. Okay. The next title is osmotic pressure. What is osmotic pressure? Of course, you should be studied osmosis in biology. It's when liquids, material, move from inside to outside the cell, or from outside to inside the cell, in order to balance the liquid state. Here we have the osmosis. Definition of osmosis is movement of particles of solvent through a semi-permeable membrane. Through a semi-permeable membrane from low concentration of solution to high concentration, which means from the side of the semi-permeable membrane that has less solute to more solute, which means more solvent to less solvent. What is semi-permeable membrane here? What is semi-permeable membrane? Semi-permeable membrane is a barrier that allows passage of some particles and blocks others. Allows passage of some particles and blocks others. Of course, the cell membrane is a semi-permeable membrane because it allows passage of some particles that the cell need and blocks other. And of course, when there is a lot of solvent inside the cell, the movement is the opposite from inside the cell to the blood or lymph. So this is osmosis. Let's have a look at the figure here. Here we have pure solvent and a solution of 1 molar sugar. And here the barrier in yellow is the semi-permeable membrane. In the beginning, the movement of the solvent from low concentration, because this is 0 concentration, into 1 molar, which is the high concentration, the movement here is more solvent moves from what? From the solvent side into what? Into the solution. This causes raising the level of the arm of the solution and dropping the level of the arm of pure solvent, as you can see here, raising the level of the solution and dropping the level of the pure solvent. Would this raising in level of the solution arm, would it raise until infinity? Of course not. It would stop. When it stops, osmosis stops, but it doesn't mean the movement of the particles and both sides of the semi-permeable membrane stops. Why? Because the movement will continue, but equal rates, which means movement of the particles of solvent will be continue, but equal rates. As you can see here, we have 2 arrows leftward and 2 arrows rightward. When would osmosis stop? When the pressure that exerted by this column, by this arm on the semi-permeable membrane can stop it. In this case, we're going to call this pressure, the pressure that stops osmosis, we're going to call it osmotic pressure. So what is osmotic pressure? It's the amount of pressure that stops osmosis. Amount of pressure exerted by this column that stops osmosis through the semi-permeable membrane. What is the relationship between the osmotic pressure and the concentration, or the molar concentration, or the particles of the solute? Here we have directly proportionality. It is just like the elevation of boiling point, also directly proportionality. Here also between osmotic pressure and the molar concentration of the solution, also directly proportionality. So we have here 1 molar. If it was 2 molar, it would raise more. If it was 0.5 molar, it would raise less. So here, the relationship between osmotic pressure and the molar concentration is directly proportionality. Higher concentration causes a higher osmotic pressure, which means the arm here, the level of the arm here will raise more. And so, what we have here, so we have some justifications. We have some cells get shrink and some cells get expand. When the osmosis occurs from moving of water from inside the solution to outside, the cell will shrink. When the cell absorbs water and the movement of water from outside to inside, the cell will expand. So it depends on the cell and its surrounding. If the concentration inside the cell is higher, the water will enter inside. If the concentration outside is higher, the water will move from inside to outside the cell. Okay. When the size of the cell doesn't change, of course, when the concentration out and in are equal, which means also means the ratio of the solvent to other material equal, because the cell doesn't expand or shrink when concentration inside and outside are equal, like blood and lymph in vertebrates, which means animals that have backbone. Okay. We have here homework, how the cell expands, explained. Of course, here when the water moves from outside, from the surrounding, inside into inside the cell, it would expand. Okay, this is all about the 4 colligative properties. 4 colligative properties, but when the solute is non-electrolyte, we talked about the freezing point depression. We talked about the vapor pressure. Of course, this is also drop, and elevation of boiling point, and also osmotic pressure, which is also directly proportional to molality. Next lesson, we're gonna study the same properties, elevation of boiling point and depression of freezing point, but when the solute is electrolyte. So I wish you get benefit from this mini lecture and have a nice day.